Hello friends, welcome back. Today we are going to see our point conservation of energy for a single particle. This is the last point from conservation theorem for a single particle. After this we are going to see the internal and external forces acting on a system, and after that we are going to see the concept of center of mass, which are very useful for studying the conservation theorem for system of particles. Now we are going to see conservation of energy for single particle. Okay, generally we know energy is nothing but the combination of kinetic energy and potential energy. Okay, in this video or in this lecture we are going to see how kinetic energy and potential energy is conserved. So let's take a look here. Work done by external force F upon a particle going from point 1 to point 2 is given as work done for a particle for going from 1 to 2 is given as work done is nothing but force into displacement. And suppose the particle is here, so particle want to go from point 1 to point 2. At that time some force acting on it, and due to applied some force it will does some displacement. That displacement is nothing but dr and applied force is F. So to calculate entire force we have to take integration. That's why the equation is nothing but work done for displacing a particle from point 1 to point 2 is equal to integration over the path 1 to 2 F into dr. Okay, what is meant by work done, how we have written this 1 to 2, how we have taken the limit 1 to 2, all the things clear here. So we know, we have seen the Newton's law. In that Newton's law, the second law of Newton's second law, the law of force, which is given as F is equal to ma. Okay, we know a is nothing but acceleration, and acceleration can be written as dv by dt. So just putting this value here, F dot dr, just take this quantity, only this quantity, and put it here, F into dr. For F we are taking F into ma, and a is nothing but dv by dt. So our equation becomes F dot dr is equal to m into dv by dt into dr. Okay, but we know dr is also something displacement. So dou r by dou t, which is a small displacement, that's why we are taking dou, which is partial, dou r by dou t, and for full differentiation dt. Just put this value and put it here. Okay, then what will we get? M into dv by dt into dr by dt into dou t. Just cancel dt. We know dou r by dt is nothing but v. This displacement is nothing but some distance divided by time is nothing but velocity. That's why for this dr by dt we will write v. So dv, our equation becomes m into dv into v. Just take this d outside, okay, and take this m inside. What will we get? D into m into v square. Just take this whole value and put in this equation here. So what will we get? Wf work done from point 1 to 2 is equal to integration 1 to 2 m into v square into here. Okay, no, here is d. So this is our expression, but we know differentiation and integration are opposite quantities. Okay, that's why what will happen, this derivative and integration cancels for each other, just remains limits. So we will write m v square limit from 1 to 2. Okay, so upper limit minus lower limit, whenever we are putting limit, at that time we will use upper limit minus lower limit. Okay, so this here we get only m v square, just multiply it by half. What will we get? Half m v square limit from 1 to 2. Now we have to put limit. What is the limiting condition? Upper limit minus lower limit. So 1/2 m v square at point 2 minus 1/2 m v square at point 1. We know 1/2 u v square is nothing but kinetic energy, and which is denoted by T. That's why work done for a particle displacing from point 1 to 2 is equal to kinetic energy at point 2 minus kinetic energy at point 1. So here we have calculated our kinetic energy and we have given this equation number 1. Now just we will turn towards our potential energy. Here the force is given as F is equal to minus of del V, and this minus of del V is nothing but conservative force. So firstly, what is meant by conservative force? Conservative force is nothing but, suppose your particle is here. We have applied some force and this particle displaces to point 2. Here the force is F1, right? And again this particle is displaced from point 2 to point 1. F12 which is equal to minus of F21. Okay, means what will happen? This is for traveling particle or displacing particle from point 1 to point 2. We have applied some force which is equal to F12, and for displacing particle from 2 to point from point 2 to point 1, the force is nothing but F21. If a force will take similar path or take similar amount of or require similar amount of force to displace particle from one point to another point, there if the force is same, then that force is called as conservative force. Okay, you got what is meant by this conservative force? Whenever we will require a same force and it will take a same path, at that time we will call it as a conservative force. So we know our conservative force. Okay, we know our work done. So that's why W of 12 is which is equal to integration 1 to 2 minus of del V into dr. Just take this minus outside, integration from 1 to 2. This del is nothing but d by dr. So dv by dr into dr get cancelled, and integration of dv is nothing but v, and integration from 1 to 2. Here minus sign is outside. So for neglecting this minus sign, just put we know limiting condition, upper limit minus lower limit. Just reverse it, lower limit minus upper limit. We will neglect this minus sign, so we will get v1 minus v2, and we get our potential energy v1 minus v2. This is our equation number 2. Just equate equation 1 and equation 2. We will get T2 minus T1 is equal to V1 minus V2. Just rearranging, T1 plus V1 is equal to T2 plus V2. Okay, what will it say? T1 plus V1 is nothing but E1, and T2 plus E2 is nothing but E2, which is nothing but sum of kinetic energy plus potential energy is nothing but total energy. So energy required at point 1, which is equal to energy required at point 2 is same, and this proves that the conservation of energy. The significance of this conservation of energy is nothing but we are studying it from very low standards, that nothing but the significance is nothing but energy can neither be created nor be destroyed. It may be converted into one form of energy to another form of energy. This is the significance of this theorem, and this whole conservation theorem is used to solve the complex problem. Okay, now we have already studied here space and time coordinate. We have studied from there from our first lecture to this space and time. Okay, coordinate system, then linear momentum, angular momentum, and this is our conservation of energy. Newton's laws. We have seen all this for a single particle. Now we are from next lecture we are going to see all the things for system of particles. If you don't get anything from these videos, then please comment me in comment box, or you can ask me anything at my Facebook page. We are providing our Facebook page link in the description of the video. तुम्ही जर अजून आमच्या चॅनलला लाईक केलेलं नसेल, सबस्क्राईब केलेलं नसेल, तर आमच्या चॅनलला सबस्क्राईब करा आणि व्हिडिओ पाहत राहा. थँक्यू.